Hi everybody, this is Mr. Cure, and recently we've had a lot of school closures because of the weather. So we had a lot of snow, a lot of ice on the road, and what happens is we've had a few snow days. And to prevent this, the city goes out and plows the roads and actually applies some salt, some rock salt. So you can see here some rock salt being applied, and what it does, it melts the snow and ice. What is rock salt? Well, rock salt is actually a crystal, and the crystal here is made up of sodium chloride. So we're going to have a sodium and a chlorine together, and this forms this little crystal. And when you look at the crystal, if you were able to look at it under high power microscope, you'd notice that it forms a little network. This network is called a crystal lattice. And you'll notice that in here we've got these sodiums, which are positively charged. What they're doing is they're located in between the negative chlorine ions. So what happens is we've got these negative and positive ions, and they're all attracted to each other in this network. So this attraction is actually called an ionic bond because it's the attraction between differently charged ions. And if you look in here closely, you notice that for every single sodium, there is one chlorine. So our formula for rock salt would be NaCl. So let's take a look at how this actually forms. So what we have here is to form these ions, we're going to have some kind of transfer of electrons. And this is something you've done before. So let's look at a situation here. So we know sodium, it's in group 1. So let's draw a little Lewis dot diagram for sodium. And what it does, it wants to desperately lose an electron in order to become stable. So it wants to lose the electron and become a cation. And then chlorine over here, what it has 7 outer electrons. And what it wants to do, it desperately wants to pick up electrons. So it's going to pick up the electrons from sodium. And it's going to form this chlorine anion with a negative charge. And the attraction between these two, as I said, is called an ionic bond. And what's going to happen, as I said earlier as well, is we're going to have several of these ions joining together. So we're going to have these cations being attracted to anions, and anions being attracted to cations. This whole thing is called a crystal lattice, and this little unit in here, we'll learn later, is called a formula unit. So let's look at bonds. So bonds form between any two atoms. Sometimes the bonds are between ions, as we saw with ionic bonding. So we're going to have a cation and an anion, and the attractive forces between them are going to be the ionic bond. Sometimes it's in here between atoms, and the atoms actually are not forming ions. They're forming much stronger bonds we call covalent bonds. So this is a molecule, so we call these molecular compounds. So this is the attractive force between these. So what happens is, let me just bring this up a little bit. Chemical bonds are the attraction or the attractive forces between ions or between atoms. Now, in ionic bonding, what there's a give and take. You saw there's a transfer of electrons from sodium to chlorine. And it happens that the metals lose electrons, become positive, and are cations. And we saw that the nonmetals, they want to typically gain electrons and become negative, or anions. And the oppositely charged ions attract each other. And when they attract each other, they form this ionic bond. So let's look at an example where we'd have magnesium and chlorine joining together. So let's take a look at that. So what happens with magnesium, remember magnesium is in group 2. It has 2 outer electrons. And because it's group 2, it would prefer to lose these electrons. So it'd like to form a cation. Chlorine over here, what it wants to do, it is in group 17. So it has 7 outer electrons. And what it would like to do is it would like to pick up electrons from the metals. So it's going to pick up one of the electrons from magnesium. We still have this other electron that has to be given somewhere from magnesium. So we have another chlorine coming in here. And this other chlorine comes in and it picks up the remaining electron from magnesium. So what ends up happening is the magnesium is going to form a cation with a charge of 2, and the chlorine, we're going to have 2 of them. Each chlorine picks up an electron and becomes an anion with a charge of 1 negative. Here we go, just like that. And what happens is the attractive forces between the cations and anions here, that is the ionic bond. And you'll notice that there is something called the zero-sum rule. The overall charges have to be 0. So what happens here, we've got 2 positive charges and 2 negative charges, which gives us 0. So that's a summary of ionic bonding. Now, where this comes from, if I want to write down the formula for magnesium chloride, I have 1 magnesium, 2 chlorine. So the formula would be magnesium chloride, MgCl2, indicating I've got 2 chlorines. Now, if I wanted to do this using the crisscross technique you did in previous grades, it'd be the same thing, just write down the common ion charge. So magnesium, group 2 would be 2 plus, a chlorine would be negative. So you just cross over and you end up with MgCl2, and that's your formula here. Okay, so what we have here, this is the periodic table, and I just want to review some of the common ions that are going to be forming. So if you look at group 1, all of these have 1 outer electron. So what they want to do is they all want to lose this outer electron. So all of these are going to have a common ion of 1 plus. In other words, we want to have an ion with 1 plus. We call this the valence as well. Group 2, they want to lose 2 electrons. So you're going to have a 2 plus charge. Group 13, 3 plus because they want to lose 3 electrons. Carbon could be either gaining or losing, so it could be 4 plus or 4 minus. Nitrogen would like to pick up 3 electrons as well as all the other group 15, so it's going to pick up 3 and have a valence of 3 negative. Oxygen picking up 2 electrons with the other group 16 would be 2 negative. Fluorine and the other group 17 want to pick up 1 electron, so 1 negative. And finally, the noble gases, no valence. So this is the common ion charge, but this is also called the valence. It's going to help us write formulas for these different ionic compounds. Remember, what happens is for ionic compound, we're going to have a metal joining with a non-metal. So it's going to look something like this. There we go. So one of these positive ions is going to join with a negative ion, and that's going to form our ionic compound consisting of a metal and non-metal. So let's look at some examples in our workbook right now. So when you're naming ionic compounds, it's a very, very easy formula or strategy to use. All you do is you write down the name of the metal first and then the name of the non-metal, and you add an "ide" ending. Metal plus non-metal and "ide." So I'd recommend you jot this down. So let's look at an example of sodium chloride. So here for sodium chloride, I write down my metal, which would be sodium. And then chlorine would be next. I'm going to add the "ide" ending instead of "ine," so chloride. There we go. And that's our name of our ionic compound. Now, if we're going the other way, writing down the formulas, you have to use the valence or the common ion charge. So let's look at magnesium oxide. So magnesium oxide, you're going to have a charge for magnesium, typically of 2 plus. Oxygen is going to be 2 negative, and we're going to cross over. So our formula here at first glance would appear to be magnesium 2, oxygen 2. But what we always want to do is always want to reduce with ionic compounds. So you're going to have magnesium and oxygen. So this would be my true formula. So let's review. You write down the symbols, write down the ionic charge or the valence, use the crossover technique, and reduce if necessary as we did over here. So what I'd like you to do, try these out. We have a few examples here, and then check the pause and then check your answers. All right, make sure you've got the correct answers. They're very straightforward. Again, when you're doing the formula, you write down the element symbols, use the valence or the ionic charge, cross over, and you write down the formula. And sometimes you have to reduce. When it comes to naming, write down the metal first, then the nonmetal with the "-ide" ending. The "-ide" ending indicates this is a binary compound. So use the "-ide" ending for uh, compounds that have very, very simple, only two atoms inside of them. Okay, now that we've done simple binary compounds that have typical metals and nonmetals, let's look at some metals that have more than one possible charge. So transition metals in some of the group 14 metals, what they can do is they can have ions that are different charges. So for example, iron could have ions with a charge of 2 plus or some ions with a charge of 3 plus. We call these multivalent. And what you have to do is you have to memorize the different possible uh, valence or charges associated with each of these. So you have to know the fact that iron has 2 plus, 3 plus, copper could be plus or 2 plus. Zinc is always going to be 2 plus. Silver is always 1 plus. And then tin and lead could be 2 plus or 4 plus. You have to memorize these, and I'll show you a system of keeping track of them. So here's my problem. I've got iron here. Both of these are iron chloride. So my problem is the following. I have to call these iron chloride because they are binary compounds, but they have different formulas. So when I'm naming these, I can't just call them iron chloride. We have to have a system to name these. So let's take a look at this. So over here, I'm going to have chlorine. We know chlorine has a charge of 1 negative. Well, because I've got two chlorines here, the iron here must have a charge of 2 positive. So to show that, what we often do is use Roman numerals. So I'll call this iron 2 chloride. Here, I'm going to have my chlorine, charge of -1, and here the charge of iron is going to be 3 plus. So I'm going to call this iron 3 chloride. So by using these Roman numerals, we can distinguish between these uh, multivalent or atoms with multiple charges. We call this the Stock method. And you just use Roman numerals again to indicate the charge of the ion. So let's try a few of these down here. So why don't you write down the formula for these four different compounds using the Stock method, using the Roman numerals, and then pause the video and and afterwards check your answer. Let's see how you did. So what we do here is we're going to write down the formulas for these. So I've got nickel. So you don't know nickel, but it tells you nickel has a charge of 2 plus. So write that down, 2 plus. Chlorine we know is 1 negative, and then you simply cross over. So our formula for nickel chloride be NiCl2. Now iron 3, we're using the 3 plus version of iron. And oxygen we know is 2 negative. So the formula here, crisscross, would be 2 irons and 3 oxygens. Now, this is tin. You have to be careful with tin. So tin here has a charge of, we don't know what the charge is. It could be 2 or it could be 4. So we work backwards. So we know that fluorine is negative, and there's 2 fluorines. So the 2 must have come from the tin over here. So now this is going to be the version of tin that is 2. So we call this tin, Roman numeral 2, fluoride. Now be careful with this one. This is lead and oxygen. So what you know here is that oxygen has 2 negative charge, and both of these are even numbers, so that must mean that the lead must have a charge of 2 plus. So this is the 2 plus version. So because of that, we're going to call this lead 2 oxide. That's it. Now next we're going to be looking at an older system of naming. It's called the classical or Latin system. So it's based on Latin names of the elements. Let's take a look at this. So the old Latin names, for example, for copper is cuprum. And what you use is you add a prefix, or suffix, sorry. So use cuprum, use the cupra part of it. And if you're the the higher version, you'd use ik of the charge, and the lower version of the charge would be us. I think of it like this. Us is 0 for the O, and ik looks like a 1. It's larger. So us is smaller, ik is larger. And we use this instead of Roman numerals. Let's look at a few examples here. So if I've got copper, I know copper can have a charge of 1 or 2. So instead of using Roman numerals, we're going to be using the us and ik. So the lower charge is going to be us. This would be cupris, and this would be cupric. Similarly, iron could be 2 or 3. So ferrous is 2, ferric is 3. Stannum and plumbum have similar charges. So 2 would be the us, 4 would be the ik ending. So what we do, this is an older version. We don't typically use it anymore, but some chemicals are labeled in the older version in different textbooks. You want to make sure that you know how to use it. So it's very similar to, I said, the Roman numerals, except we use the prefixes. So what I'd like you to do, let's try these out. So I'd like you to try writing the formula for these using the classical or Latin technique. So us or ik ending, no Roman. All right, now that you've had a chance to practice these, let's check the answers. So for us means the lower version. So I know I can have iron 2 or iron 3. So here you're going to have the iron 2, the lower version. It's oxide, so oxygen 2 negative. So the formula here would be FeO, just like that. Look at plumbic chloride. Plumbic, ik means the higher version. And I know this is lead, so lead could be 2 or 4. So this is the higher version, so it's going to be 4 plus chlorine, negative 1. So our formula here for the crisscross is going to be PbCl4. There you go, plumbic chloride. Now let's look on this side, and now here what we have to do, we have to name these using the appropriate suffixes. So what I have here, I've got Sn, which is tin, and the word for tin in Latin is stannus, or stannum. So you have to decide, is it stannus or stannic? So let's look at this. So we know we're going to have 2 oxygens, and oxygen is a charge of 2 negative. In order to get 2 of these, the charge of tin here must be 4. I've got twice as many here. So we're going to be looking at the higher charge version. This is stannic, and then we just use the ending oxide. Here, similarly, I'm going to have sulfur. It has a charge of 2 negative, and copper here. And I've got 2 coppers. So where that 2 come from? It came from the sulfur. And there's only 1 sulfur that came from the charge of +1. So this is the lower version of copper. So copper could be 1 or 2. So this would be the lower version. So this is cupris, and we call this sulfide. That's it. So again, this isn't used commonly. I will give you a few questions on assignments, but it's just to make sure that you do understand how to use it. Primarily, we're going to be using the stock method, though, with the Roman numerals. So that's it for ionic compounds. Hope you enjoyed.